Have you ever considered the invisible forces at play when a robot arm swiftly picks up and moves an object, perhaps on an assembly line or even in a surgical setting? It is not just about the weight it carries but how that weight moves. Dynamic payload profoundly impacts a robot's performance by directly influencing its speed, accuracy, power consumption, and overall control stability. It means the robot has to work much harder and smarter than with a stationary load. The core reason lies in the principles of inertia and kinetic energy. Dynamic payload refers to the mass that a robot manipulates while that mass is accelerating or decelerating. Unlike static payload, which is just the weight held stationary, dynamic payload introduces additional forces due to changes in velocity. This increased inertia demands greater torque from the robot's actuators to initiate or halt movement, leading to higher power consumption and heat generation. Furthermore, the rapid movement of a heavy dynamic payload can induce vibrations and structural deflection within the robot arm itself. This elastic deformation directly compromises the robot's positional accuracy and repeatability, making it harder to perform precise tasks. The control system must then contend with these complex, time-varying forces, making stable and accurate trajectory tracking a much more challenging endeavor. Without proper compensation, the robot might overshoot targets, vibrate excessively, or even become unstable. To manage these effects, engineers employ several strategies. They select robots with appropriate stiffness and payload ratings that exceed the maximum expected dynamic load. Trajectory planning becomes critical, favoring smoother paths that minimize sudden accelerations or decelerations. Advanced control algorithms, often involving dynamic models of the robot and payload, are used to predict and counteract these inertial forces, ensuring stable and precise movements. An important related concept is jerk, which is the rate of change of acceleration. Minimizing jerk in motion profiles not only reduces mechanical stress on the robot but also contributes significantly to maintaining accuracy, especially with dynamic payloads. Engineers also frequently evaluate a robot's payload-to-weight ratio, which offers insight into its structural efficiency and dynamic capabilities. Understanding how flexible manipulators behave under high-speed dynamic loads is also a cutting-edge area of research, where precise modeling becomes incredibly complex. Ultimately, a thorough understanding of dynamic payload is not just an academic exercise. It is fundamental for designing and operating robotic systems that are efficient, precise, and durable. By accounting for the inertial effects of moving mass, engineers can optimize robot kinematics and control systems, ensuring predictable and high-quality performance across diverse applications.
If you love robotics, like, subscribe, and keep building with us.